Dams have long been known to affect upstream and downstream habitats for fish. Some of these effects include change in amount and timing of water flow, changes in sediment composition and volume, fluctuations in water temperature, and physical habitat barriers, most notably the prevention of spawning fish to reach spawning grounds. There are over 4,000 dams located in the state of Connecticut, with each black dot representing a dam. Less than 5% of these dams are classified as large dams, that is, being greater than 10 meters in height. The remaining 95% are composed of a majority of run-over-the-river, surface-release dams that simply allow water to flow over their tops when water levels are high enough. The area that I chose to study for this video was Furnace Brook in Windham County, Connecticut, my home state and county. I chose this area as there is a fairly high number of dams in a small run of this brook, which joins other rivers through several industrious areas. The perceived and actual effects of these dams has shown some interesting results. This study area is composed of 6 run-of-the-river dams, spaced out over the relatively small distance of only 7 kilometers. The Furnace Brook joins the Middle River in Stafford Springs, Connecticut to form the beginning of the Willimantic River. Both Furnace Brook and the Middle River were vital water power sources for industrialism in Stafford Springs. The Willimantic River then flows through Willimantic, Connecticut, and was used to power multiple thread factories and cotton mills, giving Willimantic the nickname Thread City. Dams were first built in Connecticut during the 1600s and continued to be built for several centuries for various needs, such as industrial use, water supply, fire protection, and mechanical power. As the needs of the populations have changed, so has their use or need for dams, leaving many of these dams abandoned across Connecticut. The effects of dams on Furnace Brook are clearly evident. The dams have broken the brook down into several segments and several species of fish are present overall, yet not one species is found in all segments. This indicates that the presence of dams prevents the spreading of species into the different segments. This will have effect on the biodiversity and localized ecosystems of each of the segments. The more common migratory fish in Connecticut are the American shad, Atlantic salmon, short-nosed sturgeon, and American eel. With only one of these species present in these waters and in only one of the segments, it is clear that migratory fish cannot pass these dams. Furnace Brook continues towards the ocean, specifically Long Island Sound, joining into several other rivers with many more dams between the two. Without mitigation such as fish ladders and fish passes being installed, these sections of Furnace Brook will remain fragmented. With the run-of-the-river design of these dams, these more modern mitigation techniques could prove to be costly and arduous to design and install at these sites. However, the benefits of their presence at these dams and all dams along this waterway would be beneficial to all species of fish.